So we are going to cover the laws of exponents, and we are going to essentially just review all these so that they're kind of fresh in our mind. So let's just cover the basics. So if I had 5 times 5 times 5, I could write this in a shorthand notation like that. 5 to the power of 3 is what we call it. And if we had something a little bit more generic, if I had a times a times a, and it just went on forever, but there was n of these, I'd write it as a to the power of n. So what we say is that a is the base and n is the exponent. Okay, so now our rules. So if we have a to the 0, that's just going to equal 1, and that's like what we have a divided by a. Now if we have a to the power of 3, we have a times a times a. If we had a times m times a to the n, that's a to the m plus n. So that would be like a to the 3 times a to the 2, which is a to the 5, 3 plus 2. And that is the same as a times a, which is the 3, a to the power 3 times a times a, which is a to the power 2. So that does work. Okay, good. So we've shown that. Now, if we had a m over a n, that's the same as a m minus n. So if I had a to the 3 over a to the 2, that would just be a to the 1, 3 minus 2. And that's because I would have a over a and a. So 1, 2, 3. Yeah, that works. We get a as well. Now, if we have a to the power of m to the power of n, that's just equal to a to the power of m times n. So if I had a to the power of 2 to the power of 3, that's a squared times a squared times a squared. And if we use this rule, we just see that that's a 2 plus 2 plus 2, which is a to the 6. So that is the same as 3 times 2. Okay, so that's good. We also have a times b to the n is the same as a n bn. And that might be something like 5a to the power of 2. That's the same as 5 times 5 times a, which is 5 squared a squared. And I believe there's one last one, and that is a over b to the n is the same as a over n, b over n. Whoop, put a 2 in there. And that would be like if I had a over 2 to the power of 3. That'd be like a over 2 times a over 2 times a over 2, which is 1, 2, 3 a's and 3 2's. So we've just kind of covered all of our exponent laws. And this is going to be useful when covering radicals.